All right, welcome to Product Spotlight. I am Dave Cooper. Centuries ago, the master builder was responsible for all aspects of building creation from design concept through construction completion. Decisions were made with practicality in mind. Early consideration was taken on how the assemblies would be physically built, operated, and modified. So why did the combined role of the architect, engineer, and contractor deteriorate? And how is technology reuniting them in a way that traditional means never could? As the construction of the world's most famous Gothic cathedrals often took centuries to build, clearly more than one master builder was responsible for the outcome. Fast forward a few centuries as today we explore how the role of the master builder changed and how technology is transforming a centuries old sector in ways that we could never have imagined. Again, all without paper. Welcome to the age of the digital master builder. Today we will meet Chungqing Li, founder and CVO of Creod, as he shares with us the rise of the digital master builder. I love that name. Chungqing Li is an award-winning entrepreneur, the founder of CVO and Creod companies. He spearheaded, financed, and designed a pavilion for the London Olympics in the summer of 2012. The project was DFMA focused and was paperless from design, engineering, manufacturing, and assembly. He's developed Creod integrated DFMA intelligent automation software on Dassault Systems 3D Experience, a platform which automates and generates detailed designs, manufacturing code, and bill of materials. That's right, the bomb. We couldn't bring all this to you, though, without our sponsors. So a big shout out to Forward Solutions Group for allowing us to deliver these examples of construction innovation. Forward Solutions Group is helping others to succeed where others have failed. Learn more about Forward's recent acquisition of Moducore, an ERP solution for the offsite manufacturing industry. Reach out to Ben at forwardsolutionsgroup.com to find out more. And also a big shout out to Howick Ltd, who has a long history of innovation in cold form steel manufacturing and produces innovative precision roll forming technology for customers throughout the United States and the world. You want to check out their machines buyer's guide for offsite modular construction with light steel framing. Check them out at howickltd.com. And again, a big shout out to them because we cannot bring you all these great people. And heck, without Howick, I would not have met Chungqing Li, who we're about to have on the show because we met at their Steel Horizon event in England. So without further ado, let's welcome Chungqing Li to the show. I'm going with Lee from here on out. How you doing, Chung?
Very well, thank you. Thank you for having me. Thank you for the grand introduction. I'm so pleased to be here. Thank you so much for the opportunity.
Yeah. Well, listen, I'm pleased to have you here. This is fun. I saw you speak once before. You bring a lot of energy. You have a different look and a different outlook on how to move things forward. So super excited to get into it with you. But first, Lee, we want to know everything about you from the moment you were born to this very moment in time. Don't leave out any of the good stuff from the hospital, or we will call a family member and have them on the show, and it might just embarrass you. But listen, give us your 2-minute elevator pitch on where you come from and how you got to where you're at, and then we're going to jump into Creod. Go ahead.
Yeah, long and short, my name is Chungqing Li, aka Li. I'm the founder and CEO of Creod companies. I was born in China originally. I came here when I was a kid. I studied art and design architecture here, and later on I started my own practice, and then for my own architectural design practice as well as a software development company, as I couldn't convince many contractors and developers to use my workflow and technology, so I started my own construction company as well. We produce the software and then we're utilizing it, and then in the real world, which is very exciting times. So this is us.
I love it. It is you. So you gave an amazing presentation that I saw, and I was just like, we just have to have you on to talk about this. This is everything that we talk about. How do we move the industry forward? What is happening to the master builder, and how are things changing? So, and I know you're going to take us on an entire journey about this conversation. So why don't we just hop right into it? You want to jump into the presentation?
Yes. let me, one moment, please.
Yeah, I have it up on screen, so whenever you're ready.
Yes, okay, 1 second. Okay, so yeah, I'm the founder of and CEO of Creole Companies. So Creole is a visionary brand of pioneering transdisciplinary architecture, development, innovation, technology, and the construction companies. We call ourselves digital master builders. We develop Creole's integrated DFMA intelligent automation software to create changes in the AEC industry. So it consists of an award-winning architectural design practice, and this is the second company which was formed in 2020. We developed the software ourselves, and as we couldn't convince any initially couldn't convince any developers or contractors to use our technology in the workflow. So I started my own construction company, and we have been involved and also building a range of residential projects in London and Southeast England. We're also in the process launching Creole Homes using our technology and the building systems. So today I'd like to briefly introduce talk about the issues we have in the AEC industries, and also a solution what we have and what we build at the moment, and there's some case studies as well. So these are just example of our projects, build projects.
Wow.
And there's a residential project in Fulham in London. We're the principal contractor, and this one we involved with my partner engineer, IDs Global. They specialize in light gauge steel frame. So we were developing the software, using this as a case study, and also involved this project in Brighton, housing apartment block, light gauge steel frame, and also with the architects as well for this project, from design, planning, application, and DFMA. We've been appointed as principal contractor. The projects are currently on hold because the material fluctuations. We'll wait until the price goes down a little bit. And including our own developments, we're working on that airspace development in North London. And also the forthcoming project, care homes, using our technology and the building systems, Creole Aeronautics Building Systems, aka CAPS. And also other project, my background, very creative, structural design, and also something more classic, and also facade engineering backgrounds, computational design, parametric design, helping other companies. It's one of the most international renowned architectural firm in the UK. And also been doing some really interesting project in South City. And this is the problem we have in our industry is absolutely failing badly. So we haven't had a significant, meaningful change for nearly a century, and we're still using the same workflow, which is unproductive, high risk. So according to the McKinsey research in 2017, our industry, the construction sector, is the second least digitized industry in the world, which is shocking. And the problem we have is, the information we produce for most architectural engineering practice is still manually produced or reproduced, and the request by a chain of consultants. It's very labor intensive and high risk and risky, and the whole process is opaque. People work in a silo. So which is, we have a major problems here. But the thing is, even we have the BIM solution, it's still, it doesn't work very well. The procurement method is still isolated, and also drives the price upwards, leads to reach the bottom quality and performance. And in the meantime, each consultant, they don't really talk to each other. But every single member is like an island, work on their own in a silo. So so the technology hasn't really solved the problems, and I believe that we've been hijacked by software developers. We have to learn, as a designer, we have to learn the software engineers, the workflow, the mindset, and which is sometimes is very counterproductive, anti-creativity. And we still use this, even we use the BIM software. we still use the extract 2D drawings, DWG PDFs, and sending to contractors for pricing. The way I describe it is you do this a BIM model, which has got a form of intelligence, but ultimately you issue 2D drawing packages for pricing, for delivery. It's almost like a one step forward and two steps back. So we should change the way we work, stop the drawings. We should work in a 3D environment, and I will talk about it further. And also the RIBA unproductive sequential work method. So we stop each stage and then move on to the next stage. But if you look at the automotive, aerospace, and defense industries, they use concurrent work methods, concurrent engineering process. Everybody's working at the same time and contributing design ideas, and the entire model is fully parametric. If you change one thing, everything will change accordingly, or you can negotiate with different disciplines, for the better results. And that's the problem with another problem, the sequential kind of work method. It is every single stage you can see we develop the concept design, and we always pass to the structure, quantity surveyor, and they will evaluate the costing. And usually stage 2 and 3, you usually get viable because there's not much level of detailed design. So onto the stage 4, usually we get into this not viable, it's over budget, and the entire project go into loophole. Architects need to simplify the design, and the other consultants don't want to keep out, they want more fees, etc. If you can survive through the stage 4, move on to the stage 5, usually go into the wrong procurement model, outdated methods and techniques, poor performance and delays, and ultimately reach the bottom quality. That's the typical kind of scenario. And it's a developer's nightmare because of the way we think. We started doing small development, and then if you look at the real estate development industry here in the UK, according to the government's research, every £1 spent, just 51% is retained in residual asset value, which is very, very poor because all the 49% goes to the consultancy fee, risks, and some problems. In my opinion, there must be a better way. That's why I started looking at an alternative solutions, starting with the smaller projects, leveraging technology, developing tools, programming, scripting, drive machines, and manufacturing, etc. So this is kind of the typical procurement method we use. We've got the client, we've got the consultants, they produce the design and the detail work, and it passes the building contractor, the principal contractor, and the principal contractor will subcontract to a range of contractors, and they talk to the suppliers and manufacturers and install. So this is that's what we use. Typically, the JCT design build contract. But what we're promoting is actually we're using this work method. So we have the clients, and we still have the same design team. But we use the Creelt integrated DFMA intelligent automation, which is developed on the Dassault Systems 3D Experience platform. So it automates the building systems. So it generates manufacturing code, for example, the light gauge steel frame systems. So it automates the 100% detailed model or virtual twin, and in the background, it generates manufacturing codes and shop drawings. I don't know the purpose of shop drawings, but we need that for legal purposes. But more importantly, it's manufacturing codes. So you can pass the code to any manufacturer, any Howick machines really across the world, so you can get the quotation. And anything can be quantified, like bolts and nuts, toilet doors. It will generate a shopping list of bill of materials. So understand. So it gives you clarity and certainty. When people ask how much does a building cost, so this gives you an idea, and all you need to work out is to find the right contractor and do price. So the way we do it is we price the manufacturer, we cost everything, and then we price the job. So this is our labor cost, and that's our profit, and how long is it going to take this. And then we're in the process of developing our own Creelt integrated smart solution online platform. So we bring all the suppliers on the platform. So when we generate a manufacturing code, so you can procure from our platform. And then so what we're introducing is transparent open book contract. This will actually utilize at the moment.
So let me ask you, if I could. So is it an end-to-end solution? Where an architect or somebody can use your system designed for manufacturer assembly, whether it's modular, panel, wood, or steel. Does that make a difference? And then it creates everything that one needs, not only for the BOM, the bill of material, all the way through the manufacturing of the design and all the codes that would go into a Howick machine, for instance, or another software, and then spits it out at the end and also gives you the total cost of the build?
Yes, that's almost correct. Yes.
Come on.
Yes, almost. Yes, it's correct, actually. That's we're trying to. My job is that I'm a very simple person, trying to simplify the entire process.
Yeah.
The problem that at the moment we have a different software. You're jumping around, from Revit to Rhino, Grasshopper, Tekla. I call this a monkey business. As soon as you move away from this platform, you model, you lose intelligence. The model is no longer, a parametric. So
right.
That's why we're trying to integrate everything. And the Dassault system, that software, the platform, is, people from aviation, defense, automotive industries. They use the software to design, develop, engineering, build stuff. So this is a commercial decision. We're developing tools and software on this platform, which is I'd like to show you some examples later on.
Yeah.
So it gives them a better idea. Yeah. So this is the kind of this is our concept. From you can just bring some reference surfaces, just a concept design geometry, and using our tool. It takes you from the concept design, which is the beginning of the RIBH stage 2. You can almost arrive at the end of RIBH stage 4. I'll show you some examples in a moment, some videos.
Mm-hmm.
And this is again, we're trying to eliminate simplify the process, and also I love quantity surveyors, but in this case, from the pre-sale stage, as soon as you develop the design to the delivery, we can just price a job without quantity surveyors. We talk to the manufacturers or suppliers directly, get quotes rather than estimation. And this is this image you've probably seen this before.
Yeah, sure.
That's what inspires me from the automotive industries, object-orientated, paperless. It's not about assembly sequencing, how things are made, how you put them together, from design, engineering, manufacturing, assembly to operation and the maintenance. So this is kind of we're borrowing brilliance from aerospace, automotive industries. And I'd like to show you the first project we did as a Creole Pavilion for the London Olympics in summer 2012. Okay. And this was the very first project I did, leveraging technology, computational design, digital fabrication, and which plays a very important role in which could play a very important role in our in the AEC industries. So when I had this concept, when I showed the design concept to my colleagues, they said it's impossible. And the challenge it had was not only the design issues, but more importantly, to raise the finance, and the questions arise: who's the client? Who's going to pay for this? Where do you exhibit this? Who's going to build this? But I couldn't answer all the questions, but I decided to go ahead. I had nothing to lose, really. So I started pitching, this idea to companies. And after thousands of rejections and failures, I managed to convince, good companies, Hewlett-Packard, Bentley Systems, Capney, and manufacturers like Tensile Fabric. And they kindly sponsor their products, materials, and services, made this project successful. I'll just show you some videos. This pavilion, it's 3 identical elements. Each pavilion consists of 997 unique pieces. If you put in the wrong component in the wrong place, the next part won't fit. So this required aerospace accuracy. So I had to use, I had to program, we call it manufacturing modeling, and manufacturing ready model. And we detail model every single component and turn this into a G code. So robotic arm could understand it and manufacture this, each part. It was a pure R&D process. It was very, very exciting. I was very nervous as well because it's a high risk
bet.
project. When I asked my QS friends, and I said, how much does it cost? And he said, look, the old Torino behind you, that the original budget was 385 million pounds, and the final cost was over 1 billion. So, yours, it's about 1 billion pounds plus contingency. It could be two, which is high risk. But
Right.
considering Lee, you hadn't built anything in your life, and this is so complex, double curvature, etc. And good luck, young man. So
It worked out, right?
It did, yeah. It was challenging, but it's just it did work out actually, yeah. Luckily, yeah. And more importantly, I didn't just design a pavilion. Actually, I created a workflow, explored new working methods. So simplify the using technology, programming, scripting, working with other consultants who are very talented consultants, the geometry expert, Evolut. These guys are mathematicians, They just program things. It's genius. And and also my structural engineer Rambles as well. And we just made this thing work, and the only paper we had was this one. You can see it's assembly diagram. We didn't have an iPad, back in 2012. So, this is the only assembly diagram. So the project manager on site just highlight what's been built, what's been assembled. And the great thing about this, it's a very complex project. It didn't require skilled workers. It was just a range of students, volunteers who helped us build this. All we had to do was put the right components in the right place. And thank you. As you can see, the steel frame as well. We modeled this. You can see this the plates on the steel hoops. They're in different angles. The question is, how do you describe that on the 2D drawings? This is pointless to draw them in 2D. So we modeled everything in 3D. I worked with a steel fabricator based in Nottingham very closely, understanding if the steel plates for welding, where do we chamfer, how do we cut them? We just issued the final 3D cutting list and 3D model, and they just built the steel hoops for us, steel plinth for us within 1 millimeter tolerance. It did work actually. And the next one is, when I was working with IDs Global, my structural engineer, Nigel, has been very, very helpful supporting us. Gives the opportunity to get involved. This project is the most existing terraced commercial unit, and then turned into flat and coffee shop. It's hybrid structures, steel frame structure, hot roll and light gauge steel frame systems. And the next one, we get involved further and work in the background,
right.
Testing out technology as well at the same time. And so what we've done is we developed this, I was working with the Howick, Nick, CEO of Howick. He was very supportive and helpful and gave us all the technical information. So we developed, the system based on the engineering rule,
Yeah.
and creating templates. So the principle is, just a reference surface like that, and you just it creates a wireframe. So we pass the structural engineer, they can carry out structural analysis, say this double step here or triple step there. So it automates and generates a fully detailed 3D model. So in the background, it creates manufacturing code and also shop drawings. So this is the range of tools or apps we have developed on the Dassault Systems 3D Experience platform, which is very, very powerful. So from the light gauge steel frame, hot roll steel frame, to facades, and next challenge we're going to crack the MEP side, which is another challenge. We're working on that as well with engineer from aerospace and automotive industries. Very talented team we have. And also, I can see as you can see, from very concept design stage, just some reference services. It just automates the brickwork, for example, or brick slip, the full cladding systems.
And how accurate is that?
It is very accurate actually. The structural opening has got the intelligence. Say the brickwork doesn't match the structural opening exactly. Sometimes the structural opening is here. You want to cut the brick by 11.798 millimeter. So you would do full size brick in half. So So you will adjust itself. You have
Sure.
to change the design accordingly rather than trying to match the architect design intent. That's the structural. That's the opening we want to be. But it doesn't look very nice, in the real world,
Right. Right.
Yeah. So we eliminate the problems, and also this is a case study. We the architects for this project in Surrey. The client hired 2 architects before us, both from Grand Design, very famous. Unfortunately, they couldn't get a planning permission because the site is on the green belt, also the conservation area. So yeah, we had to demonstrate the quality design, sustainability, the methods of construction, etc. Yeah, we did get a planning, and I also did the detailed design stage as well. So this is the tool we have developed. We use the garage as a test in the moment. So Creolt facade. As you can see, there's a reference surfaces. All you have to do is a click on the panel. My 5-year-old kids can do that. My receptionist can do that. And it's just done. You click and it's done without knowing what just happened. So the panel's done. And the next click, it just, it will generate all the cladding rails. So for the cladding panel, we can, it automates CNC code and also shop drawings. So you can pass it to the manufacturer or even the steel fabricator. So this system we use is Kingspan because in the middle of the pandemic, we were considering to do, doing our own system, but in the middle of the pandemic, we couldn't do any testing. So the Kingspan was a safe kind of approach. So it automates everything. 2 simple clicks, the job is done. And this is the entire, the facade system of the project. The whole building is parametric, light gauge steel frame, and the cladding, insulation, and also we developed a tool for the internal, boarding, plasterboard, everything. So so this job, the client, we made the 12 changes. If you work in a traditional way, architects only do the design intent,
Right.
They just do this change the building form. If you want to get into this the detail stage, down to bolts and nuts, you need to get to you need to have a principal contractor on board, and you need to get the own subcontractor, facade engineer and the manufacturer. If you make changes, say once or twice, you can get away. But if you change 12 times, come on, man, we need to charge you more money for this. So just financially, it's not viable enough. For many clients, we face the same problem. If you don't have the intelligence, you have to redesign the whole thing. The entire design program pushes back, and it costs you more money as well. So this is kind of for us, for this job, we changed 12 times. It was viable because just a few clicks and the job is done. And the client said, we don't have a budget for underfloor heating. And the one place, we have now. Let's do underfloor heating. Things like that. Can you make the pitch, the roof slightly steeper? Things like that, So this is the kind of the templates, fully parametric templates with constraints as well to understand, the maximum minimum size of each panel. And hot rolled steel, light gauge steel frame to the to the cladding system, automated. So I was very pleased with this. It's just fast and efficient. So what we're creating here is it's not just accuracy, efficiency, but certainty, financial certainty. That's the very, very, very important as for anyone really, especially the developers or the clients, and also the drawings, assembly drawings is automated. It tells you how many types of panels and the quantity per type, and also the shop drawings. You can pass it to the steel fabricator or manufacturer. I did a test. I gave a design intent, just elevations to the facades company, and later on I issued this shop drawings and manufacturing code. It turns out it's £24,000 cheaper than the because they had to price something higher. I did raise the question, why was it more expensive? They said, well, I had to price something higher to price the risk. Right. We only have a design intent with some dimensions. But once you get into this level of detail, this is it, They give you a quote, a proper quotation. It tells all the bolts and nuts,
For sure.
I was quite pleased with the results as well. So we also developed a beta tool, just assembly sequencer, just to try to simplify the process, So we got a foreman on site. They got not very skilled workers. They just need to put right component in the right place. Once it's done, and it just validate by the site engineer or manager really, and then and it validates. You can click Lee and Dave. You assembled these 5 panels today, for example. So so it's a quality control. And another thing is we're trying to introduce. From the project now on, we're going to simulate the construction process. So we can break down how many components can be assembled in a reasonable weather, not the heavy rains, etc.
Right.
So we can work out how long it takes, and a transparent, a labor, the costing really. And more importantly, what we're trying to introduce for the future project, when we simulate that, we can break down how many, the quantity, the portion each team, what they can deliver every day. If they move on, if they can build faster, we'll pay them more. So this is encouraging people to work faster, work harder. So ultimately, our budget doesn't affect. There's a pot of say £800,000 to assemble this building. It doesn't affect the cost. If they finish faster, everybody wins.
Sure.
So that's a kind of as a workflow, change the the mindset. Otherwise, the people just take the time, just slowly.
Absolutely.
They don't get more money if they work fast. So we encourage them. So this is the project we are. My investor, they bought this plot of land with planning permission granted, and yes, we're the principal designer, we're the project manager, and also the principal contractor. And we just use a Dassault system, understand, we did a point cloud, we scan everything. The site is very tight. I just didn't know what's happening next door. As you can see the basement here. I had no clue. Couldn't find any information. They didn't have planning permission or building regulations. Just the grey area. So we did a 3D scan. We checked. It turns out the flat, the basement in the corner, the internal wall is only 107 millimeter from the boundary line. So assuming that the retaining wall is 400 mil, which means that the retaining wall is on our side. And our initial design had a ground beam and mini piles along this boundary line. If we did it, we'll be in a huge trouble. We'll face massive claims against from the 5 neighbors next door. So because we can see what's going on, luckily, and yes, we changed the design accordingly before the construction started.
Just because you did a 3D scan, what did you use to do the 3D scan?
It's any 3D scanner, Faro technologies. They've been very helpful, and they do 3D scan and turn the 3D points into mesh. This is quite very interesting. So the entire project, we had to do some 2D drawings for the basement subcontractor. Setting out drawings, but for us, we don't need any 2D drawings at all. So we also simulated, assembly sequencing. As you know, my background is not a building contractor. I work with my team. We simulate the process based on the program and elements. So if any changes, we can see the impact. For a few down the line, months down the line.
Right.
It's all about certainty, understand risk management as well, which is very important. So you just simulate everything, tells you when to do that. We can do even something more detailed, the operation, how the crane, the lorry comes in, turn, and the high ab drop, the props, everything.
Now, does that give you also the cut and fill for the land and everything around the building as well?
Yeah, everything. Everything. You can go as far as you can. And obviously the contractors say, the 10 millimeter tolerance. So we get Faro Technologies. They came outside, they did a scan and did a point clouds, and they brought in this the 3D mesh. I just did a compare, because it's quite important. We do the prefab, the offsite construction. The ground beam, is very important. It needs to be as accurate as possible, But how do you see that? I need to see it. So I bring the 3D scan and check it. If it doesn't fit, obviously it's too late. It's already been built. Instead of pointing fingers, we just fix it. We can see the difference and then alter it accordingly, rather than the next contractor comes in and says, "Oh, the groundwork's not ready," and then they start claiming, it's not their fault. Obviously, you've got 5 guys on site, £3,000 a day claim. You don't want that. So yeah, we just completed the basement. I'm very excited, and we'll move on to the next phase, the main building, which is hot roll and light gauge steel frame. We're working on that. I'm working with the IDs Global, my structural engineer. So yeah, that was the initial design, and we're making some changes as well.
Yeah. Hey, we just had while you're talking about hot steel, we just had Tata on yesterday, right?
Yes.
Or no, Monday. I'm sorry, Monday. I'm losing track.
I was watching it.
Yeah. I mean, so for people out there they're looking to partner with general contractors and designers to come up with better ways of doing their steel as well, which is super cool stuff.
Absolutely.
And they're one of the largest in the world.
Yeah, it is a way forward, actually. People think, obviously steelworks, is high carbon footprint to produce. But as you can see, these panels we produce, they're standard heights.
Yeah.
So what we're encouraging is, instead of recycle, we don't recycle. Our slogan is don't recycle, reuse. And this is when we produce the Creole homes. That's exactly the same principle. Standard modular parts, panels. You can just create anything you like.
Yeah. Why don't we take a moment here and just let everybody know that we are live on LinkedIn, YouTube, Facebook, Twitch, and Twitter. So get your tweets on if you're out there, and make sure you tweet us. And if you're not following us on YouTube, you're wrong. Get out there and follow us and subscribe. We are growing faster than I can even ever have imagined. So thank you to all of you out there. And if you're not following Creod and Chun Qing Lee, you better be following them, because they are making a lot of changes. And we got quite a few comments and questions to get to here in just a moment, which we will. And we'll give shout outs to everybody that's watching as long as we still have some time left. But we're at about 40 minutes right now. Lee, how much more we got on the presentation?
One more time, yeah.
Let's do.
So actually it's finished. We do other stuff, simulation, virtual twins, and see our projects. This is kind of how we coordinate. We're using Unreal Engine, which we use a lot. We're developing tools on that as well.
Sure.
So, very exciting times. I think the presentation's done. If you have any questions, please go ahead.
And now, is that the Olympic piece that you did?
Yes, that's right. I brought this in. This is a walk around, And the building we're about to start early next year, we're using the same workflow.
Right.
So
the material that we saw the robot cutting was more of a wood material. Is this a wood material with some special coating on it?
It was timber. It was eco timber from Norway, Norwegian eco timber. Very, very. It's beautiful, Hackney timber.
Yeah, for sure. All right, well, I love it. So why don't we go to a couple comments here real quick and just say hello to a few people and a couple questions as well. So Michael Bruce, now this is somebody who knows something about digital laser imprinting and taking points like you were talking about for bringing data into systems. Sitting in the Gulf Shore, Alabama today, really like the master builder approach. We use another digital prototyping tool like Catia, I think I said that right, and are convinced that this type of software is the best approach to use for modular building. So Michael, thanks for joining us, and I always appreciate it. Now, no stranger to danger, Joel Hutchins in the house. You know Joel Hutchins by chance? Lee, how do you not? Everybody knows Joel Hutchins. He's like the most famous guy, one of the most famous guys in the world. I got a few of those now. I got to be careful. Great work with design automation, leveraging Catia. How do you leverage technology to drive consistency in project delivery and then have that inform design in the future? Secondly, why Catia? Are you able to see it, Lee?
Yes. Okay. I'm just switching the screen. Yes. Well, this is quite important, really. Is that the automation is that the key is the commercial decision, really. 2 reasons. That's from the design point of view. We're creating a range of engineering rules. Something will definitely work because the people will make mistakes, if you know, all well skilled workers, they come and go for many reasons. You know, we work with some consultant when I just started as a CATIA Dassault Systems, and he left, so he put me in the limbo, and I realized, you know, there are very few people in this world know how to use the software. You know, people from AEC industry, they don't use that. There are very few people, but they also use a Revit BIM software, which is I see this as just dead end. It's hopeless. And then so it comes to the point is it's a high risk. Very few people in this world can use it. So we have to develop a system that can automate, that can capture knowledge and prevent mistakes. And at the same time, get a job done with a few simple clicks. That's the step number one. And step number two, from the developer point of view, is all about the certainty and transparency. As you can see, every single development, at least 20% over the budget. 35% easily. You know, this is kind of it's a high risk. So we try to minimize the risk and then, you know, give certainty to developers. That's the notion behind it. Yeah.
All right. Follow-up question from Joel as well. Great parametric design here, leveraging OTS software. What exactly is proprietary here other than the design process itself?
Well, is it similar? Well, I can answer the question similar to what I just answered earlier. It's not just about the parametric. It's the model itself is parametric, but also it's very slightly different methods, automated approach, and it has got the flexibility to make changes. One of the job we are testing now is from the early design stage. For example, from the early concept design stage, we're testing different facade systems. As you know, the steel price gone up to 200-300% since the pandemic, the last two and a half years. So the way we evaluate, the risk is if we use the aluminium cladding panel and the price keeps going up, so we need to test. Maybe we can consider alternative, like for example, composite materials. So that cost is steady. It doesn't go up too much. It hasn't gone up too much. So this is kind of from the early design. Before you submit the planning, we test different building systems, how they look, and is it appropriate for the planning, from planning point of view, the choice of materials, the finishes, its materiality, texture, etc. So this is kind of how we approach. And then with the client and the quantity surveyor, we make agreements on this is material going forward. And this is, from a commercial point of view, this is quite efficient, de-risk the projects. What you don't want is to propose some materials and then a year later in the planning, it's no longer viable. You can't just simply change it.
Yeah. Well, you two should connect because Joel plays in the same arena that you're talking about as well. So you all should be exchanging phone numbers, in my opinion. I like you both very much. Super cool. All right. No stranger to the show, Henry Mickelberg. Why would you take client requirements and then silo into various disciplines and then amalgamate in Creod? Surely just use the cost plan as the spine and extract any Ds to suit your clients.
The client is very important, obviously. Ultimately, if you talk about making ideas, can ideas be made and how? As you said earlier, the master builder theory, the traditional meaning, architecton in Greek in the 16th century, it meant chief builder. The architects were not only the master of spatial effects, but they were also closely involved in the construction process and costing everything. But unfortunately, we have shifted away. Architects more like the flapping around, doing the interesting stuff, without knowing or understanding the cost implications. So this is a gap. That's architects used to lead the design process. Now, because the incompetency, they're just part of the design team. You've got so many surveyors around, so many design consultant team. Because you can't deliver. So that's why what we're trying to do here is, this is the software we have developed and still in the process of developing. It allows us to regain the traditional meaning of, a master builder, the power of a master builder, So that's the idea. That's the approach.
Awesome. Appreciate the question, Henry. All right, we got another question coming from YouTube. Nolan Brown, ADL Ventures. What's happening, Nolan? Thoughtful and exciting stuff. What software solutions are you using, and how broadly are these capabilities disseminated throughout our ecosystems? And I know we talked about a couple of these softwares already, but go ahead.
Yes, I think our approach is integrated. If you think about, in the aviation automotive industries, in order to win the contract, say General Motors, for example, any car manufacturing companies, in order to be to be the supplier or manufacturer, part of the supply chain, you have to use certain tools, for example, Dassault Systèmes CATIA. So but in the AEC industry, it's almost like the Wild West. People have different things going on. And that's why when you come to the point, you have to sketch out this and that, come all together. They all static geometry. They don't have the intelligence. And then also from the product life cycle management point of view, it just doesn't work like that. You need to be more, I call it a authoritarian approach, everything, you need to use that tool to deliver. That's it,
Yeah, for sure. For sure. Well, let's do a quick shout out to Greg Ugoldi. He says, awesome videos. Greg is the head of the National Association of Home Builders, which is the largest or second largest lobbying firm in Washington, D.C. And the guy that updates the president a couple times a year on housing here in the United States. So, Greg, always glad to see you. And guess what? He's always coming from Twitch because he likes to hang out with the young gamers. So, appreciate that. Always, Greg. All right, we got Michael Bruce making me eat my own words. See, Dave, 3D scanning is the missing link in most construction projects. He's right.
Yeah, he is actually. That's why we did the 3D scan. Imagine if we didn't do the 3D scan of the basement and then we did something. We could do some trial pits, see what's going on next door. But the best guess is a trial pit and look at some section drawings. It's not accurate enough. We need to see. We need to have the God's eye to see what's going on exactly next door, the site and context, and we'll make an informed decision before we start construction work. This is very important. It's all about the risk management. You need to see. If you don't see it, you don't know what the problems are. Once that starts, I'm afraid it's too late.
Well, that's it. But I mean, that's everything with, offsite construction, industrialized construction, modern methods of construction, whatever we call it. You got to get the planning done up front. You need to think it through all the way. And the digital tools to scan is just one of the things that we have now to help us mitigate some of the risk that, like you're saying, of the things we cannot see.
Exactly.
Yeah.
We're in the perfect timing. We have all the technologies available. Yeah, just utilize them.
That's right. That's right. All right. We got Judy Donnell. Judy, good to see you. Does your program measure the carbon levels?
What does that mean, the carbon?
Well, I think
carbon levels. Oh, sorry. Not yet. No. Well, we can do the simulation. Using and other products. Anything can be done really. At what price? That's the question.
Yeah. Well, Judy's another super hard worker at the NAHB, just so you know. She, at least last year, I think you still are, you were the chair of all of the vendors. I think she had like 80,000 vendors and, partners within the NAHB that she helps work with to get the word out on what they do and all their products. So good to see you, Judy. I hope you are doing well. Yeah, it's 80. I don't know what it is, the members, but I can't remember the associate members. Geez, I couldn't get it out of my head. There you go, Judy. I got it for you. Big deal. And another volunteer. She travels all over. She's also with 84 Lumber here. All right. So
we're taking that very seriously. Obviously, if you look at timber construction, it seems like low carbon, more sustainable materials. Ultimately, if the timbers come from Canada, shipped to Germany or Austria, manufactured there, and sent it to the UK. All this timber that has got chemical treatment towards the end of life cycle. You can't burn them because it's toxic. You have to do landfill. So you need to think about the bigger picture. Sometimes timber is not the most sustainable materials.
Right. Well, you know what? There's
not necessary,
There's definitely two sides to that conversation, and we're not going to get into it today on that. Yeah. All right, so Lee, we are just about out of time. I know we didn't cover a lot of the things, but we had a couple questions, from our end that I wanted to make sure that we covered with you. And let's see if we can fly through them. So, from your view, BIM for MMC and offsite construction, what's your view on using BIM for MMC and offsite construction?
BIM is, to me, is a dead end. Is if you do the BIM modeling and you end up issuing 2D drawing packages and schedules, it defeats its purpose, and it doesn't make any sense. And it's not a manufacturing ready model. It's not intelligent enough. So for the DFMA purposes, so you need to get into the industrial software, that coding and then your code that drives the machine. I know there are some plugins for BIM modeling, but the superstructure, facade, that's just one thing. But other things like MEP side, you're just not ready. I think, it's a dead end.
So I guess my next question would be, I mean, there's a lot of software out there. There's already, like, even people in the comments have already, come up and developed some of their own forms of similar things that you're doing at Creod. So what makes you start, a software development, and what difference are you personally trying to make?
There's a sense of urgency and frustration, really. Because as I mentioned, the monkey business, people using different tools. And this is the issue that geometry has got no properties, no intelligence. It's not parametric. It just doesn't work like that. Imagine if you design a car in that way. Every single car would crash because by the time you receive that document, the designers have made another 5 revisions. You can't keep up. So it needs to be concurrent engineering process. Everybody's on the same platform, works together, on the same page, rather than different things going on. And by the way, just made a change to give you another 3D model. And my colleague, actually, just briefly mentioned, a colleague of mine, he's an MEP subcontractor. They have the clients, a big consultancy firm. They did this very detailed BIM model. Guess what? They don't share the 3D model because of the intellectual property. They just issue the 2D drawing packages. Question is, what's the point? Why do they do that?
Well, I mean, that's why we have the show to discuss these types of things. So, all right, Lee, we are out of time. Is there anything that I didn't ask you that you want to make sure that everybody out there knows about you or Creod or what's in the future? Now's your chance to put it out there.
Yes, just to keep an eye on us. We're doing quite interesting, and we have a prospect in investors. We're launching a platform which integrates the supply chain, and this is what we're working on. So as a start is that automation and automates manufacturing, code and building materials. The next challenge, it will integrate the suppliers, manufacturers together, and let's do that. Let's make things better.
Let's make it better. And that's exactly it. It's all about working together. It's about collaborating to drive this industry forward. And that goes for yourself, Lee, and Joel, and Henry, and Judy, and Greg, and everybody else out there that commented today. I hate when I do that because then I'll miss somebody and they get mad. Michael's out there as well. Lee, thank you so much. I appreciate you taking time all the way from across the pond in England to join us today. And I hope if all you guys are out there watching, reach out to Lee, learn about what Creod's doing. Make sure you discuss things. You might find some collaboration between here in the United States and around the world as well. It happens more often than you think. That's the whole idea of our show, is to put people together and make real connections so we can build it better. That's right. Hashtag build it better. So I love it. Love it. Look at that. Jamie Parr in the house. I didn't catch that one. Better delivery, baby. That's right, Jamie. Good. Hey, MR. See, I got to put these things up. MR Rafat. Great discussion. All right, everybody. That's a wrap for today. Thank you for watching. Listen, Lee, do not go anywhere. I will come right back to you after the outro, and the rest of you have an awesome afternoon. And it's Wednesday, hump day. We're almost to the weekend. That means one thing. That means Coffee with Dave this Saturday. So stay tuned and make sure you tune in Friday with our show with Mark Bare Naked Willie. Bye now.
Absolutely. Thank you. Thank you so much. Thank you, everyone.